so let's take a look at this next section. So this is 7.2, and we've actually had this starter question before. What does the word rational mean? Okay, the root word is ratio, but what is a rational expression? It's a fancy word for a what? For a fraction. Whoops. It's a fancy word for a fraction. All right? So it turns out that writing radicals is not always the best way to represent a root, a radical expression. So what we're going to do is we're going to be able to use our calculator just a little bit in order to find square roots and cube roots and fourth roots and so forth. But if you look at your calculator, you probably don't have a fourth root button or a 17th root button or something like that. But we can still have the calculator figure those things out. Okay? So if we've got square roots, those are pretty easy. Now we know what the answer is to each of these. We talked about how to do these problems yesterday, looking for groups of 3 here. So I've got 3 3s, so I can take one on the outside. That's 3 4s. So the answer here is 4. Now we're going to type this into the calculator, and here's how we do it. If you want a square root, we use a fractional exponent. The exponent is 1/2. If you want a cube root, yeah.
Is that a 9 or
Where?
49.
Oh,
yeah.
should be a 7. Okay. It's a 7 with a funny haircut. Okay. All right. So we're going to type this into the calculator. So we're going to do just like square root. So here's the square root button. If I were to go to the home screen, clear everything off. If I hit square root 25, this is going to tell me the answer is 5. If I do 25 and then I raise that to the 1/2 power, the 1/2 power is the same as the square root. Now if I do 1 divided by 2, that's 25 to the 1/2, right?
When do you put that parentheses?
Thank you, John. I do need parentheses. Okay, don't forget the order of operations. If you remember PEMDAS, or please excuse my dear Aunt Sally. And this is a common misconception, so let me just point this out again right now. This is the order of operations. You've all heard that before, right? This stands for parentheses, right? This stands for exponents. This stands for multiplication and division, and this isn't a 6-part list. Go through and do the parentheses, then go through and do the exponents, then go through and do the multiplication, then go through and do the division. It's really a 4-part list. When you get to multiplication and division, you do the multiplication and division in order from left to right, then you do the addition and subtraction in order from left to right. So if I were to type that into the calculator, it knows the order of operations. It's going to do 25, it's going to raise it to the first, then it's going to do the division. So it's going to do 25 divided by 2. It's going to give us 12.5, and that's the wrong answer. So I'm going to recall that. I'm going to type it in the right way, put parentheses around that. That's 25 to the 1/2. Okay? So if I type that in, that's going to give me 5. That will calculate square roots for us. Now, if you're computing square roots, the radical sign, because you've got a button on all those scientific calculators to do that for you, that's the easiest way to do it. But if you're going to do cube roots or fourth roots or fifth roots, you need to use those fractional exponents. Now, some fancy calculators, some of the graphing ones, have an xth root button, if you want to call it that. You can type in the number of the root and then just type the radical sign, and it'll do it for you. What's that?
It has that X root on this one.
Does it really? Okay. All right. So I'd rather you think of this in terms of the fractional exponents. So if I were to change this and do 49 to the 1/2, just to verify that that wasn't a fluke that it got it right, there we go. Okay. Now if I want to do to the 1/3 power, so I'm going to do 27. And then, and then I'm going to raise that to the 1/3. This should spit out a 3, and it does. Okay? Any questions there? So please make sure you type it into your calculator correctly. All right. Any questions there? Okay, raise your hand if you've seen that before. You knew that you could put roots into your calculator that way? Okay, excellent. About half of you. Okay. So we could refer to that as like the nth root or the xth root if that's the way your calculator has it. So if I write x to the 1 over n, or a to the 1 over n, I can write that as the nth root of a, or if I see something like this, I can write it like that. So if this says express using a rational exponent, this is the 10th root of 43. So I could write that as 43 to the 1/10. This is the 6th root of 4x. Now notice that 4x is the radicand, so if I'm going to make this the 6th root of 4x, can I just do this? Got to have parentheses, because we want that to apply to everything there, so I'd put that in parentheses. This is the 17th root of 9x squared. So again, on that one, I'm going to write 9x squared, put that in parentheses, and raise it to the 1/17. Okay. Any questions? Okay, I want you to take a good look at that last one then. Okay, if I use the properties for exponents that you reviewed in 1.6, and I applied it like this. Let's say I wrote this as 9 to the 1/17, and then I wrote x squared to the 1/17. Okay, I can break that into two pieces. Oops. Make that a little bigger and make that look better. Okay, this one's fine, it's a fractional exponent. What about this? What if I have a power raised to a power? I multiply them, right? What's 2 times the 17th? 2/17. That's easy, right? So I could write this as 9 to the 1/17 and then x to the 2/17. Okay? Any questions there? And that's just using properties of exponents that you reviewed in 1.6. We're good? Well, if you look at this one right here is different than all the others. It doesn't have a 1 in the numerator. So we can actually take advantage of that to rewrite radical expressions a different way. So here's what we want to keep track of. Rational exponents can be expressed in several ways. So if I have a to the m divided by m, or m divided by n, this right here is still the base. This right here, I like to think of that as the exponent, and that right there is the root. So I've got the base, and then if I've got these two parts of the fractional exponent, the numerator is going to be the exponent, and the denominator tells us which root we're working with. So it's going to be the nth root, that's going to be the index, and then I can apply the m as an exponent either inside or outside. Now, both of these are valuable. A lot of times we'll write it like that, it depends. But there are many times where writing the m, writing that exponent on the outside is a little bit better. It keeps this radicand right here a little bit smaller. It's usually easier to find a root of a smaller number and then raise it to a power than to take it, raise it to a power, and then try and find the root. Yeah.
So it doesn't matter which one we do?
No, it doesn't. Okay, we're going to use them both. It just depends on the situation. We'll find advantages to both of them. Okay, are there any questions? Okay, so we're going to point out those advantages right now. Let's take a look at this first example right here on 3. So 125, there's the base, here's the exponent, and there's the root. So if I were to just rewrite this as a radical, here are my two choices. I can write this as a cube root of 125 squared, or I can write it as the cube root of 125 and then square that on the outside. It doesn't make any difference, but which of these two would probably be easier? Square on the outside. Because if I were to multiply these together, 125 squared, that's probably going to be like, what, 15,000 or something? I mean, it's going to be a pretty darn big number. Okay? So then we'd have to find the cube root of that big number. Let's keep the number fairly small. Keep that radicand small. What is the cube root of 125? 5. Square that. 25. Now, if we type this into the calculator, it should give us the same answer. So let's do 125. Make sure we type it in correctly. We're going to need the parentheses, and then we're going to do 2 divided by 3, and there's our 25. Okay? So on this one, it's much easier to leave that number small, leave the radicand small, find the cube root, and then apply the exponent, then square it. So let's look at the next one. Same type of thing here. Notice that the denominator is a 2, so this is going to be a square root, and I'm going to write it as a square root. And then I've got a choice. I can write 9 to the third, or I could write square root of 9 and then cube it. They don't quite cancel each other out because this is a square root and this is cubing. Okay, so they're not exactly inverses of each other. But on this one we can do 3, cube that, we get 27. Any questions there? Okay, now we mentioned this before. Let's make sure we're clear on this. Okay, this was in 1.6. We talked about how the negative in the exponent means something. It means a word. It means what? Not inverse. Reciprocal. It means reciprocal. So if we're going to do this problem right here, this rational exponent actually has 3 parts, and they all mean something different. Okay, that negative there means reciprocal. The 1 is the exponent, and the 2 is the root. So this is the square root. Well, let's see. Let's take care of the reciprocal first of all. Let's do 1 over, and then this is going to be the square root of 9. Everybody okay with that? So what's our answer on this one? 1/3. So I think I mentioned before, a lot of times we don't like fractions very much, but they work really well with radicals. Okay? So there's some really nice properties here. Let's take a look at the next one. Okay, does this bother us that this is negative? No, for 2 reasons. Somebody tell me what they are. It's a cube root, so you don't have to worry. And are we really taking the cube root of negative 64? No. How do you know it's just the 64? Because it's not in parentheses. It would have to be in parentheses if we were taking the cube root of 64. It wouldn't matter on this particular problem, but you do need to be aware of that, especially when we're doing even roots. So this is going to be negative cube root of 64 squared. Again, if you want to do it with the 64 squared in there, that's totally okay. I'd rather do this. I'd rather do negative cube root of 64 and then square that. Now, notice we're not including the negative in parentheses. There are not 2 negatives here. There's just that 1 sitting out front. So we do the cube root of 64, which we found up above. That's 4. Square that. So the answer on this one is negative 16. Any questions? Yeah. Why not? Does the 2 apply? Does that exponent apply to the 4, the negative, or both? Just the 4. If we wanted it to apply to both, what would we need? We'd need to have parentheses around that. Okay? Does that make sense? Okay. And we can also check this way. Now that we know how to type these into our calculator, let's grab the calculator and let's type this exact expression in right here. So we're going to do negative 64, then I'm going to raise that to the 2/3. And if we did it right, we should get the same thing. Remember, got to do it correctly by hand, got to type it in correctly into the calculator for those to match up. Okay, are there any questions? Okay, all right, let's take a look at the next little group here. For example 4, it says write using a rational exponent. You don't have to calculate anything. All it says is write using a rational exponent. So maybe there's a time when this isn't the most advantageous way to write it. Maybe we don't want to write down the cube root of 100,000. So we write 10. There's the base. What's the exponent? 5 for the exponent, 3 for the root, so that's going to be 5 over 3, and that would be our answer written as with a rational exponent. And on this problem right here, take a good look at this one because this is a little bit more complicated. There are several ways you could work this out. I'm going to think of it like this. This is 9xy raised to the 1/4. All of that is raised to the 1/4, and then all of that is raised to the 7th. So what's my exponent going to be when I'm all done with this? Okay, 9xy. It applies to all of that, and we're going to raise that to the 7/4. Any questions? Yeah.
So if we already knew that the outside exponent goes on the top and the index is going to be on the bottom, we just do that.
Sure. Can you go from the problem directly to the answer? Yes, you can, especially if you realize that the 4, the root, applies to all three of these factors, and so does the 7. It would be a little bit different if we did something like this. This might be a little bit tricky. What if we had a z out front, and then we had the 4th root of 9xy, and we raised all of that to the 7th? Then it would be z to the 7th, and then a parentheses 9xy raised to the 7/4. Okay? Just got to be careful about what it applies to, and that's why those parentheses, like we've talked about, are really important. Okay, good? Okay, flip it over on the back side. You'll notice that on the back side, we've just got a bunch of problems. These are out of the textbook, and they're very similar to the ones that you're going to see on Math Excel. So they've got the same type of instructions and all that sort of stuff, so hopefully this is pretty easy. It says, write an equivalent expression using radical notation and, if possible, simplify. So this is a 4th root of 81. So I'm going to write 4th root of 81. Again, I mentioned a common mistake yesterday that a lot of people forget to write the index. We just get used to, oh, they're always radicals, they're always square roots. Make sure you write the index. That tells me I'm looking for groups of how many? Groups of 4, okay? Please don't lose this skill to be able to factor those and find those groups of 4. I realize you could type that into the calculator and get the answer's 3, but much better if you can think about it in terms of the number of factors. Any questions there? Okay, let's take a look at the next one then. What root is this? 4th root again, right? We're looking for groups of 4. Now on this one, we had a group of 4 3s. Do we have any groups of 4 here? Nope, so we're done right there. That's the answer, can't be simplified. Okay? Next set of instructions. Write an equivalent expression using exponential notation. So we're going to write this as an exponent. So this is going to be C and D. Both of them, please put them in parentheses, raised to the 1/3.
So if we wanted to, could we distribute it through?
Could you write it as C to the 1/3 and D to the 1/3?
Yeah.
Sure. Probably not a very useful or efficient way to do it, but yeah, you could.
So like you're not going to ask us on a test, make sure it's distributed and simplified all that?
If you were to do this on a test, after all the discussions we will have had by next Friday, yeah, I'd probably come over and thump you or something.
Okay.
Honestly, I'd probably take off half a point. Okay. That's a silly way to write it, because think of what you have to do here. You have to compute this, and you have to compute this.
Okay.
Compute them completely separately, write them separately, write more work. I mean, we want to do things as efficiently as possible. Okay?
Main question was for the next problem, just because I can see all the exponents already in there.
So let's take a look at the next one. With that in mind, go ahead and do this one. So could we write it this way? I mean, it applies to all of these. Okay, but if we acknowledge the fact that, gosh, each one of these is different, here they both had the same exponent, okay, so it'd be a little bit silly to break them up. If we wrote this one as x to the 3/7, y to the 2/7, and z to the 2/7, okay? Now, can you simplify any of these? You can't, okay? So it wouldn't be a big deal if you wrote it either way. Which do you think is probably the more efficient way to do it? Yeah, probably this one, okay? Okay, next one. Write an equivalent expression with positive exponents and, if possible, simplify. So remember, if we've got a negative exponent, if it's a factor with a negative exponent, you can move it from top to bottom or bottom to top and change the sign. So this is going to be 3b, and if I move that into the numerator, that's going to be a to the, it's now positive 5/7. So we don't really need to write the positive there, right? and that's it. Any questions? Okay, let's take a look at the next one then. Exponent is -3/5. So remember, there are three parts to every exponent. There's the sign, there's the numerator, and the denominator. What does the negative in the exponent mean? Does it have anything to do with the sign of the answer? No, it's not going to make the answer suddenly be negative. It literally means reciprocal. So this would mean, I take this and I flip it over. So I'd take 8yz, let's put it on the top, and let's put 7x on the bottom, and then that would be raised to the 3/5. Now, to my mind, there's not much else we could do with this, okay? Because it says write it with positive exponents and simplify if possible. What root would this be? Fifth root. So we're looking for groups of how many? Groups of 5, okay? But that's if we wrote it as a radical, right? Then we could take something on the outside, okay? We can't do that with any of these. So I'd probably leave it like that. I suppose you could write this 8 to the 3/5, whoops, y to the 3/5, z to the 3/5, 7 to the 3/5, x to the 3/5, okay? So this is kind of an extreme case of doing this. Does that look like a good idea? A little on the silly side. This is probably the best way to write the answer. If you have trouble with MathXL writing it in the right form that it wants or something like that, just view an example real quick, see what it wants you to do, and then type it in that way. Okay, are there any questions there? Okay, then the last couple. We want to make sure that we always remember those simple exponential rules that we've learned. So if I have a multiplication of powers, so if I have like x to the second times x to the third, product of powers is what we call this property. What do we do with the exponents? Add them together. So that would be x to the 5th. I kind of think of it this way. I think of a hierarchy of operations. So we've got addition, multiplication, then we've got exponents. Okay? Whatever you apply, you kind of drop down one step. So if you're doing an exponent to an exponent, you'd multiply them. If you're multiplying them, you drop down one, and then you just add them together. So here's that case where we have power to a power, exponent to an exponent. So what do we do with those? Just multiply. So this is going to be x to the 12th. And here I'm dividing them, so what would be one step below division? Subtraction. So there we're going to get x squared. Okay? Now, I think this is where it gets a little bit interesting. It says, use the law of exponents to simplify. Do not use negative exponents in any answers. Okay, so everybody watch, please. This right now is a 4th root, and this is an 8th root. If I put the two of these together, just like what I had up here, I'm multiplying these together. Product of powers. What do I do with the exponents? I add them together. So this is going to be 5 to the, let's see, I'd have 1/4 and I'd add 1/8. So I've got to figure out what a 4th plus an 8th is. 2 8ths plus 1/8, 5 to the 3/8. So now instead of having a 4th root and an 8th root, they're all just 8th roots. So it's possible that we come up with something different as far as roots go than what we had originally. Okay? Again, you could do subtraction on this one, or we could move it up to the numerator if you wanted to. Okay? And then we just add those together. So this is going to be 8 to the 9/11. Done there. Okay, now, here's where it gets really interesting. So we saw right here we had like a 4th root type thing kind of get absorbed into that 8th root. If we look at this problem right here, this is a 12th root. And it says, use rational exponents to simplify. Do not use fraction exponents in the final answer. So what that means is, the problem's written as a radical, but can you simplify this radical? Okay, if we just use the rules that we were talking about yesterday, we're looking for groups of how many? Groups of 12. Do we have any groups of 12?
No.
No, I've only got 3. So as far as radicals are concerned, if we didn't use anything more advanced than what we already know, we're stuck right there. That's it. But if we say, wait a minute, fractions work really well with radicals, I can write this with a fractional exponent. So this would be a to the, that's the exponent, that's the root. So this is going to be 3 over 12. Well, that's a fraction 3/12. 3/12 is the same as 1/4. So this would be a to the 1/4. Is that simpler than writing a to the 3/12? Yes. And if it says don't write your answer with fractional exponents, write it with radicals, what root do I have now? I have the 4th root of a to the 1st. Now, take a look at this and compare it to the original problem. Which one looks better? Which one looks simpler? This one right here. It's a smaller root, we have smaller exponents altogether, and that sort of thing. So let's take a look at this guy right here. 4th root of y to the 40th. It's a 4th root. We're looking for groups of how many? Groups of 4. How many groups of 4 do we have?
9. No,
10, right? So the answer should be y to the 10th. Does everybody agree that even using the rules that we learned yesterday, this is going to be y to the 10th? Okay, watch what happens if we write it with a fractional exponent. This is the root, so that's the denominator. This is the exponent. So we have y to the 40 over 4. That's going to be y to the 10th. So either way, you get that simplified answer. Okay? So kind of confirms using what we did over here, it's possible to simplify this way. And let's take a look at this one right here. Again, this would be AB to the 1/3 raised to the 15th. That's a pretty ugly expression, but if I have a power raised to a power, what do I do with those? Multiply them together. What's 1/3 of 15? 5. So that's going to be AB to the 5th, or I could write A to the 5th, whoops, and B to the 5th. Okay, are there any questions there? Sure? Okay, watch. If I looked at this one, remember, there are 2 ways to write this. I can write the exponent outside the parentheses, or I could write it inside. So I could have written a to the 15th, b to the 15th, and I'm looking for groups of how many? Groups of 3. How many groups of 3 do I have if I've got 15 a's? 5 a's, 5 b's. Technically, there'd be a cube root of 1 left. Nothing left on the inside but a 1, and what is the cube root of 1? It's 1, so I don't need to write it, so I got the same answer doing it the other way. Okay, any questions? Okay, that's it. Go ahead and get going on your homework, get that done. Again, we're going to change our Q&A date to Friday.